Futurist goes beneath the trends to track the underlying forces of disruption in tech, policy, business models, social dynamics, and the environment. I'm your host, Trond Arne Undheim, futurist and author. In episode 9 of the podcast, the topic is Killer Applications in Next Decade's Edge Computing. Our guest is Carlo Daffara, CEO and co-founder of NodeWeaver. Carlo, how are you doing?
I'm doing very fine. Thank you very much. And you?
Things are great here in Boston. Where are you right now?
I am in a small city, the northeast of Italy, called Udine. It's just 100 kilometers north of Venice.
And what's going on in Udine today?
Well, sunny. Happily, most of the virus effects have been gone away. So we are out of lockdown and, let's say, trying to return to normality for what is possible.
Well, I'm glad to hear that, because I know you're originally from Padova, and so this part of Italy is among the most beautiful parts, very historical. And you went to the University of Padova, a very ancient university, and I know that it's very close to the municipality of Vo, which I was reading about during the early days of the Corona pandemic, because it's one of the early epicenters. But then subsequently they tested everyone and they got sort of things into control. How are you experiencing the early days of this pandemic?
Well, the sudden change in nearly everything was really disconcerting at first. The fact that no one is out there, everything on lockdown, every shipment, every activity suspended was really unexpected, of course. And it was curious because in the first day, everyone was saying that, it's not different than standard flu. And it took just a few days to see how many deaths we got in a very short period of time. So we changed it in a very short amount of days from this is really nothing important to everyone is at home and we don't know where we'll be out of that. Luckily, it's now more under control. There are a little bit of restarting in some smaller cities, mostly because of people flying in from other countries, but it's mostly under control.
I'm very glad to hear that. And, today's topic is not on the coronavirus, but it seems to be something that we all are dealing with all around the world. So congratulations on being able to sort of curb it. And let's move on to you, because you're the CEO of NodeWeaver, working on a cloud platform and an edge cloud platform. And you've been working, you and I met back in Brussels, I think, in the 2014 timeframe, I think, where we were both working on the intersection of open source and open standards. I wanted to ask you, is there a linear path from open source to edge computing? What's the relationship?
Well, in general, I would say that there is a linear path of open source with cloud computing in general and modern IT platforms, because most of the code in application that gets deployed in the last 5 years, nearly 70% of the code is open source. So it would not be possible to create an IT infrastructure without open source today. And open source allows for experimentation. Basically, it allows to create changes, to try new architectures, new way of doing things that allows the kind of speed that is necessary in edge deployments, in cloud deployments in general.
Got it. Few people know this about you, but you built one of the largest cow DNA databases in Europe, used to estimate the genetic properties of future offspring. I understand you also did fieldwork on a farm. How did this happen? Was this fun? Is this your, typical of your everyday working on edge computing?
Oh, it was incredibly fun. Actually, I discovered that most of the what we can call traditional jobs, like agriculture, farming, and so on, are incredibly high tech. And I ended up initially for a small project. It was designed to print QR barcodes on cheese boxes. And it was designed to allow veterinary people to check where the milk that ended up in the cheese come from. And from that, we designed other kind of interfacing tools for getting, for example, white cell counts from the milk directly into veterinary database to DNA systems. But actually, it's part of our job. We end up working in multiple verticals, in multiple kind of things, from video compression, for example, to art renovation, to architecture, to water treatments, and so on. So we take the opportunity to learn something new.
I guess this is just a testament to how far, advanced digital methods are being used, across industries, across domains, almost everywhere, which gets me to edge computing. Can you define edge computing for us? What is it? What is it not?
Well, edge computing has multiple definitions, mostly because marketing allows a lot of creativity in this. But in general, edge computing is the data processing that happens near to where the data is generated or is consumed. For example,
and why is that different from what was before? Just quickly.
Well, it's different in the fact that up to a few years ago, everyone assumed that every data source would send the data into the cloud, where it would have been processed. So every IT infrastructure basically create these huge pipes that sends sensor information and video camera data into a cloud provider. And there you have lots of processing abilities. The biggest problem is that this is basically not possible anymore, because we know that the amount of data produced by a smart factory or even a farm is so high that it's simply not economic to send everything to the cloud for processing, especially because 95 to 99% of the data is actually not relevant. Most of the data is always the same, but the problem is that you don't know which data is relevant.
That's fascinating. So we'll get into how you deal with that in a second, but I just wanted to quickly cover this. First of all, do you believe that edge computing, as you were describing it now, is a true, real trend, or is it a repackaging of some version of the cloud market? I mean, you pointed out the distinctions, but there are also similarities. So, and in answering that question, how large is what would be reasonably defined as the edge computing market? I've seen some numbers, in the 2-digit billions, for a forecast for a few years from now. What are some of the forecasts you are working with, and how large is this market, do you think?
Well, and from my point of view, the edge computing is something new, because the edge has some properties that are specific to the fact that most of this processing is dispersed in environments where there is no IT capability to, for example, to repair things if something fails. Devices are exposed to external environments, so they're under the rain, or they may be in hot or humid climates. So it's not exactly the same infrastructure that has been done in the past. It's in a sense the result of a new way of thinking by using the ideas of the cloud in terms of everything is a resource, everything is a service, and it's drivable through programmatically, and applying it to a new generation of hardware devices. In terms of how big it is, one of the estimates that we have from the 451 group is that the edge market is already in 2020 around $170 billion. And that's fairly realistic if you consider that now most manufacturing systems and most robotic systems tend to process data through local edge platforms.
Got it. Well, that's certainly a big market. And I know you work with the EU a lot on the EU projects. Are there prognostications and of this market and their optimism, for this market similar?
Well, yes, the European Commission has several initiatives that are not specifically focused on the edge per se, but more designed to make sure that Europe as a whole can be a competitive player in the worldwide market for clouds and for data in data management, making sure that data which is extracted from edge platform is processed according to local regulations like GDPR and so on. There are a few modern, more, let's say, advanced projects like Gaia X, which try to federate different levels of cloud providers, including edge devices, and several research projects on this.
Got it. Can we unbundle some of these concepts a little bit? So we've been through this distinction between cloud and edge. What is the relationship between edge computing and AI? And then maybe a few other buzzwords that I know go into this kind of soup, right? So there's the notion of 5G for mobile. There's the whole Internet of Things, IoT concept, which embeds onto what we were just talking about. I know desktop as a service, you mentioned, it shares with the cloud, that it is a service-based model. Storage area network is a kind of another term. Virtualization comes in there. And then you have a bit of a mouthful, kernel-based virtual machine monitoring. So it has to do with virtual machines. Then locality and topology are concepts. So there are a bunch of these concepts. Can you just super easily explain some of these things and how they relate to each other on the edge network?
Well, most of these buzzwords actually relates to the individual technical components that are inside of an edge platform. For example, several edge platforms use an hypervisor, which is a software component that allows to run virtual machines, which are like physical machines, but running in software only, so that you can fit more application and securely insulate one from the other. The technical let's say underpinnings of the edge are interesting from from a technology perspective, but they are probably not as interesting as the potential application of the edge in itself. AI and deep learning in general tends to be some of the most important ones because deep learning in particular has been found to be extremely effective in understanding if something that comes from a machine or from a sensor, from a camera, is interesting or not. And this is in itself an extremely important capability.
But it's also a distinction between important and not important. And I think you were talking about this. I mean, in a day and age where everyone's trying to put everything online, and especially with the Internet of Things, with all these sensors that we are developing to gather so much data, I mean, we can be fascinated by how much we could put onto the cloud and not onto the cloud, as you pointed out, and put it, leave it on the edge. But we still have to find a way to analyze for relevance and figure out, is it worth saving? Is it worth analyzing? How can it be combined? This must be a massive challenge as the data just keeps exponentially increasing. you still need some theories about what you're going to find in this data, because otherwise we're finding ourselves in an ocean of data with a hard time. But tell me a little bit about how you think about the use cases emerging from edge computing, as it is right now, and looking towards the future.
Well, one of the, let's say, nice examples that I usually make is the ability of a very, let's say, famous smartwatch manufacturer that basically took the advantage of sensor data that already is available, like, for example, the accelerometer on the device itself, the ability to identify changes in pressure and so on, to understand if its wearer has fallen and is not moving anymore.
Right.
This is an example of what we call sensory fusion, the ability to take data, which is probably not that interesting in itself, aggregate it and become something else. This ability to take information which in itself probably is not that important and make something useful out of it will be probably one of the most important capability in industrial systems and in telecommunication as well, because there is a lot of things that can be obtained by sensors that are already deployed in the world.
So the early industries that were adopting these kinds of techniques, apart from the IT industry itself, where manufacturers are arguably and maybe healthcare, what are some of the next sectors that you see? We've been talking about an agriculture example for sure, and I guess arguably I don't know if they were an early adopter, but they certainly are starting to adopt these technologies. What are some other sectors where you're seeing massive potential for these kinds of approaches?
Well, there are several examples happening right now. Video surveillance, for example, is a very consolidated market right now, because we are, let's say, deploying cameras in lots of locations to increase security, to get accountability for something that happened. But the problem is that when you have, for example, 300 cameras in a building, checking 300 cameras is simply not feasible. It's not economically sensible. So having an agent, a smart device that tells you these frames are interesting because something unusual happened, is something of value. You mentioned agriculture. I've seen lots of work in industrial sectors, in chemistry, in manufacturing, for example. We have seen a company deploying a system that uses microphones to understand if a welding robot is doing its proper work. And it's actually is taking its hints from experienced welders that are able to understand if let's say the operation has been done properly or not, simply by hearing the sound that the welder does when it performs its work.
That's fascinating. It actually reminds me of some early work done on communities of practice back in, this must be the 80s and 90s right now at Xerox PARC, and with some of the copiers that they had early on, because they were having problems with the service community and how quickly they could get these copiers back up and running. And they discovered something similar, that it was very attuned experience that was shared between service personnel that sometimes had to do with just listening to the device, like you're pointing out. So a lot of service work sometimes is, I guess also in repairing older cars, right? Just the mechanic would be listening to it. So the audible channel is an enormously rich source of information. It's fascinating that we're starting to analyze that digitally right now. Well, I think energy and finance and logistics there's just a plethora of sectors that we could talk about. Why don't we talk about some of the obstacles for a second? So you mentioned the sheer number of data points, obviously. What are some other challenges? I could imagine that this could become costly for any individual actor starting to implement it. And what are some of the other challenges that you're still facing with the edge?
Well, the edge has some very specific, let's say, properties that brings a whole set of new challenges that most of IT vendors are simply not prepared to handle. Just think about the fact that these devices, for example, tend to be used on the top of a telephone pole. So you cannot use a full-size rack server and have someone that goes there with a monitor and keyboard to deploy it. It's simply not possible. So you need to have a new kind of devices that consume less power, because sometimes they are powered by solar energy. So you cannot, let's say, employ too much memory or disk, because it will consume too much. The other problem is how to handle a whole world of devices out there. When you have companies that have 10,000 locations and you have hundreds of devices there, things like how do you upgrade your software, how you send new software there, how you check for failures, are all things that becomes exponentially more difficult at scale. So we are just in the beginning of this kind of deployments. Most of the initial deployments tend to be in hundreds of devices, and we are entering the first 1 or 2,000 locations. When you get into 10,000 locations, it's really a problem of logistics, a problem of manageability, especially because you cannot expect to have IT personnel everywhere in the world. We have one of our customers is in the middle of the desert, and they handle the power distribution for a solar plant farm. And they mentioned that it takes a repair technician 2 days by car to reach the location. So it's not that easy.
Wow, this is fascinating. I mean, it reminds me of the power of these, highly oiled logistics platforms that are going to come into play. I mean, it reminds me, I guess, of the fact that IT now is definitely going into an era, arguably, where the hardware challenges are equal to the software challenges. I mean, you're pointing out it's not just making the software run smoothly. And obviously, if you have great software, you don't need to update as much. But because of all these physical locations you're trying to empower, at some point, you do also need to go out there and, well, either set it up. And I guess, so the challenge then becomes to set up something that can last.
Yeah. This is another important change compared to traditional IT systems. We are used to think about replacing servers after 3 years. And some hyperscale vendors, like the major cloud providers, they change computers every 1 or 2 years because a new generation of systems is out with better performance and lower power consumption and so on. In many edge systems, in many industrial systems, you're thinking in terms of minimum 5 years. And some of our customers ask us for what we will have to do 10 years from now when we will start thinking about replacing things. 10
it's
years
fascinating.
Is a very
I mean,
long
we're
time.
talking about you're already building legacy. You have to build legacy thinking into the technology, because like you pointed out, if you have 10,000 locations, whether they be cameras or servers or whatnot, no one company is going to want to make that investment for security. For instance, if it's a 5% improvement in security, they're just not going, how do you even measure the benefits of changing that system out? It's fascinating. Well, 5G rollout has also been touted as one of the limitations. How do you see that? I mean, can you deploy some of these systems without 5G? To what extent does it depend on faster mobile speeds?
Well, my personal opinion is that the connection between 5G and edge systems has been exaggerated a lot. 5G is actually an umbrella of different technologies, and in general, the idea of telecommunication or networking in a more general sense is actually a spectrum of solutions that go from 4G, 5G. We have now Wi-Fi 6. We have several different interconnecting systems. All of them cover a different part of the spectrum, a different part of, let's say, what kind of connectivity you actually need. Edge deployments do not depend on 5G. 5G is actually mostly an incremental technology compared to 4G for most of the deployments. In the next 1 to 2 years, we will see one aspect of 5G which is interesting, which is the ability to do low speed communication to thousands of devices under a single cell. And that will allow probably distributed sensors for things like smart cities. But that's probably the only technology that really is necessary for edge.
I just, not that I love debunking myths, but you're one of the few that's willing to say that 5G is an incremental improvement. I mean, it sort of goes without saying that all of these numbers are, they're marketing devices in a certain sense, because of course they're real efforts. And you can't underestimate how much it's going to take to move the world from 4G to 5G. I'm not saying it's not a worthwhile investment, but as you point out, 4G is there for most of the network by now, and we might have to work with all of these other standards and systems as well. Well, how do you? Let's go into the startups first. You and I talked a little bit about this. I'm interested in tracking this environment as it evolves. And one of the lenses on the future for me and for many others is startups. What are some of the startups to watch in the domain that we've been talking about, whether it has to do directly with edge computing or it is supporting software or hardware or approaches that will foster a better, faster, bigger, notion of edge impact, in our society?
Well, there are several. Actually, it's one of the nice things is that this sector is so new, and there are so many new approaches and ideas that have been being tested in the market that the environment itself is wonderful and bubbling with new ideas. One company I really like is Swim AI, which makes an artificial intelligence and universal networking layer for the edge that allows to write intelligent applications that are designed for the edge just from the first scratch. So they are very efficient. They are able to dynamically adapt to changes in condition. Because when you are in the edge, for example, it's quite normal to have devices that appear, disappear, are connected or disconnected at the same time. One company we work for is Vapor.io, which makes a special version of, let's say, edge environments. They are designed to host traditional servers, but in a way that is much more densely packed, and they tend to be deployed at the bottom in containers at the bottom of 5G towers, for example. Hilo. There are lots of open source projects that are becoming essential and that are becoming used by many other vendors like K3S from Rancher, which has been just announced to be acquired by SUSE, a long-term open source player. Kubernetes is another of those technologies that tend to be used in a wide sense. So it's difficult. We have a small database of nearly 100 companies that we track and try to learn from them and try to see if it's possible to work with them to work together. There is no single vendor that is currently able to provide everything that can fill every vertical and that can fill every environment. So working together as a network of companies, I think, will become a necessity in the future as well.
Fantastic. You mentioned containerized computing. That's another term that has come onto the market relatively recently and seems to be fairly fundamental for some of the advances that are happening. How do you explain containerization?
Well, let's say that your edge device is able to run lots of applications at once. But for example, you may have application that comes from different sources, different providers. They may even be handled by different companies and collecting data for different applications. So you need a way to partition your hardware and divide your hardware capabilities into sections so that no one is able to go from one side to the other. In a sense, providing ironclad security about what is happening inside.
So it's for security, but it's also for speed, right?
Yeah, it's a way to have higher utilization because most of the time these devices do not do much. They tend to run at only 10% of their capacities, like a car. Most of the cars are in a park or in a garage and not used at all. Let's say that you can use your car and share it with others. Containerization is a way for securely sharing your resources with others so that no one is able to see your data and everyone is secure what happens in its own partition.
That explains a lot to me because I think I was having trouble wrapping my mind around how, for me, I like to think about what the metaphor might even just mean, but containerized for me also means, like you said, partitioning. And I didn't quite understand how partitioning something would give you more of it because, at first sight, you would think when you partition it out, you are setting out 10% that Trond works with and then 10% that Carlo works with. How would that actually free up resources? But you're saying by partitioning it, you can then decide when and how to share those resources as well. But still, as you have partitioned off some of it, I can guarantee that some of the data I don't want you to see will never be exposed, even if you are using some of my computer resources. Is that right?
Yes, exactly. In fact, this whole idea of partitioning, sharing and consolidating things together is the basis of most of the modern cloud technologies. Hypervisor, containers, and so on are just different way and different implementation of the same idea. How can I securely share something that is mine with others so that we both get a resource that we can use, but we are secure from each other?
Carlo, you're the co-founder and CEO of NodeWeaver. What does NodeWeaver do?
NodeWeaver is a company that is working on developing a sort of a universal layer for running applications at the edge. So we try to solve the problem of managing thousands of devices and how to send your software there, how to share and containerize and partition, let's say, resources in a secure way. And we tried to think about how to do it in an efficient way by using traditional cloud technologies at first. But we discovered that the edge is a different beast. It requires a different set of assumptions, and it requires a different set of technologies. It's not to say that the edge is better than the cloud or whatever. It's just to say that when you go to work, you use your tool exactly for your work. And let's say specialization is really important, especially when you have devices that tend to be very small, which means that you need to design things specifically for that.
Perfect. And can you give a very precise example of, of a client and what you're helping them with?
Well, one of the examples that we already mentioned is an automotive manufacturer that is using this welding machines. They have hundreds of welding machines in a product line, and they're using these microphones that are attached on top of the robot welder to hear the sound of the welding and how it is being done, so that if something happens, they can stop it immediately.
Got it.
We have lots of other examples. We have around 300 deployments in 15 countries. Most are really specialized. They do one job and they basically try to improve either the work condition of something that is in a hazardous environment, or to make sure that a job can be performed exactly as it needed 100% of the time.
Carlo, I find that fascinating because so much of the surface level discussion, if you read, Wired magazine or, these kind of bigger sort of myth creating engines, it's all about kind of this fascinating future. Yet a lot of the applications where IT has been successfully deployed are in surprisingly kind of niche and specialized environment just purely for optimization. But I guess the stories don't play as well, to talk about those things, but they're immensely important, I guess, when you add one thing upon another, right? And after a while, once you have automated all these very discrete kind of operations, now you're seeing efficiency effects across your whole company and ostensibly across society as many, many more firms deploy these kinds of techniques. Which brings me to this issue, Carlo. We've been talking about this and, you've been rattling off these concepts as if there was nothing to it. But you and I know that you've spent 25 years getting to this level of proficiency. How do you even begin to learn more about edge computing? And how do you, once you have learned something, stay up to date so you're able to kind of catch the latest approaches and maybe, even if your ambition isn't to just become technically proficient, at least to know when should my company start to deploy and what are some things I should pick up from other successful deployments? Where do you find this information?
Well, if there's one thing that the internet made it possible is to get as many information as you want. The problem is that the quality of the information is, let's say, varied. So sometimes you get the right stuff. Sometimes you get lots of marketing speech with no real content. If I had to start again, or to give a suggestion for someone that wants to start, is think about the real value. These technologies have a value if someone is using them. And when you think about creating something, let's say that you have to identify, for example, whether your cow is ill, or whether you want to identify if a book assembly engine is doing it properly, or so on. Think about what you're replacing, what you're doing better, what you can do better that has not been done so far. Because all the technology in the world is useless if it does not have an application somewhere. Yep. And if you think about a real application, then the actual technology is available somewhere, and it's 99% of the time it's open source and it's available to anyone. You just need to have the desire to go there and learn it.
So who concretely are some of the influencers you would say in the edge computing space that if you were to track a Twitter account or something, who are some of the people you're looking to sort of see what's going on?
There are probably too much of them to count. Actually, there are two interesting things that I've noticed. The first one is that most of the research in general in edge devices and in modern cloud platform happens outside of universities. It's done by companies like Google, like Microsoft, even Facebook, for example, in artificial intelligence and the ability to downsize deep learning technology to run on a cell phone. If there's one entity that I would really thank for their ability to help learning things is Unix, which is the Unix User Association. And they have all their conferences and their proceedings are open and freely available. And they have been one of my major sources of information in the last 5 years.
Unix.
Yes.
Well, Carlo, this is a fascinating landscape. Thank you for opening it up a little to my listeners. Thank you so much for sharing all of this information. I wish you best of luck with NodeWeaver and hope to have you on again.
Thank you to you for the invitation and to all the listeners for staying with us so far. Thank you.
Thank you.
You have just listened to episode 9 of the Futurized podcast with host Trond Arne Undheim, futurist and author. The topic was killer applications in next decade's edge computing. Our guest was Carlo Daffara, CEO and co-founder of NodeWeaver. My takeaway is that the importance of edge computing lies not in the technology itself, but in what it enables, which is a plethora of killer applications in manufacturing, retail, healthcare, agriculture, finance, energy, logistics, and beyond. The edge is based on the realization that given the amount of data we now generate, all of that data cannot always be moved around. Edge computing is also a renaissance for open source software, which is great. Thanks for listening. If you liked the show, subscribe at futurized.co or in your preferred podcast player and rate us with 5 stars. Futurized, preparing you to deal with disruption.